Module 5, Statistical Inference. Statistical inference is the process of drawing conclusions about a population based on a sample of data. It allows data scientists to make predictions, test hypotheses, and determine relationships within data. The main goal of statistical inference is to use sample data to make generalizations about a larger population. Key concepts in statistical inference. 1. Population versus sample. A population refers to the entire group you want to make inferences about, while a sample is a subset of the population. Example: if you are studying the average income of a country, the population would be the entire population of the country, and the sample would be a random selection of individuals from that population. 2. Point estimation. Point estimation refers to using sample data to estimate a population parameter. A common example is estimating the mean of a population based on the sample mean. Example: the sample mean of monthly salaries in a small company might be used to estimate the average salary of the entire workforce in a larger company. 3. Confidence intervals. A confidence interval provides a range of values that is likely to contain the population parameter with a certain level of confidence, e.g., 95% confidence. Example: if a survey estimates that the average salary in a city is $60,000 with a 95% confidence interval of $58,000, $62,000, it means we are 95% confident that the true population mean salary falls within this range. For hypothesis testing. Hypothesis testing is a method used to test assumptions or claims about a population. The two main types of hypotheses are: null hypothesis, H0 represents no effect or no difference. Alternative hypothesis, H1 represents the effect or difference you expect. Types of tests. T-test, used to compare means between two groups. Chi-square test, used for categorical data to assess relationships. ANOVA, used to compare means across more than two groups. Example: a company might use a t-test to determine if there is a significant difference in average sales between two stores. 5. P-values. A p-value is a statistical measure that helps determine the significance of the test results. It indicates the probability of observing the data given that the null hypothesis is true. Example: a p-value less than 0.05 typically means that there is strong evidence against the null hypothesis, and it is rejected in favor of the alternative hypothesis. 6. Type 1 and Type 2 errors. Type 1 error, false positive, occurs when the null hypothesis is incorrectly rejected, a false alarm. Type 2 error, false negative, occurs when the null hypothesis is incorrectly accepted, failing to detect an effect. Example: a type 1 error might occur if a drug is falsely deemed effective, while a type 2 error might occur if a drug is incorrectly deemed ineffective when it actually works. 7. Power of a test. Power is the probability that a statistical test will correctly reject a false null hypothesis. High power means the test is likely to detect a real effect if one exists. Example: increasing the sample size or the effect size can increase the power of a hypothesis test. Real-world example. Statistical inference in business. An e-commerce company wants to test whether a new marketing campaign increases the average purchase amount of its customers. The null hypothesis, H0, is that the campaign has no effect on purchase amounts, while the alternative hypothesis, H1, is that the campaign increases the purchase amount. Steps. 1. The company conducts a random sampling of customer data before and after the campaign. 2. They calculate the sample mean purchase amounts for both groups. 3. A t-test is performed to test if the difference between the two means is statistically significant. 4. If the p-value is less than 0.05, the null hypothesis is rejected, and the company concludes that the marketing campaign had a significant effect on customer purchases. Glad you could make it to the end of the module. Take the quiz to continue to the next module.